Hi everyone, and we're back this time looking at Newton forward difference approximation. So I'm not going to go through the theory on this one because it follows a very similar principle that's subtly different. And pretty much if you follow the algorithm, you should be golden. So what we're landing up doing here, the forward difference, our question says use Newton forward difference over here formula to construct interpolating polynomials of degree 1, 2, and 3 for the following data. Approximate the specified value of each of the polynomials, f of x of minus a third, if, now there's a typo in your notes, if f of minus 0.75 is equal to this, minus 0.5, that, and so forth. So, like with the previous example, the first thing you want to do is set it up in a table. Again, we want our n, we want our x, and we want our fx. Now, before, we were looking at our divided difference. This, we're just looking at the difference. So, what we're going to end up doing, we want just the difference, so let's just put, I'm going to put first difference. Our first difference, what we're saying with our first difference, I'm just going to scroll down to explain it. Our difference, I'm just going to put diff over here. And this, where before we were going y2 minus y1 divided by x2 minus x1, or considering the i's, with this I'm going to be going just a yi minus yi minus 1. There's no divided by x, we're just working with the difference. So our first difference is going to be this term here minus this term there. So if we subtract one from the other, we should land up with 0.0470625. And I've written this in red for good reason. You'll see as I complete them. So if we land up doing that for each of these, we land up with 0.3596875. And then our last one, we land up, the difference between these two lands up being 0.7660625. And let's just, because this is nice and quick to do, let's just do them all. So our next divided difference, or our next difference, so let's go second difference to diff. We are going to have the difference between these two at the top lands up being we land up with, so this is going to be that and that. We should land up with 0.31265, and the difference with the one on the bottom, stood in purple, so it's this and this, should come out as 0.406375. Finally, we can look at our third divided difference because we need to do a polynomial of 1, 2, and 3. Our third divided difference, third difference, not divided difference, third difference is going to be 0.09375. So now that we've got all of these, let's consider our formula. So it says using using the Newton forward difference formula. That right there, forward difference formula. So what is that formula? So our formula for forward difference, I'm just going to go forward diff formula. Our forward difference formula, I'm going to go P of n of x is going to be equal to, this is specifically for forward difference, so we're looking at forward terms. So let me scroll up slightly. just to make things a little bit clearer, I am going to be highlighting this over here as well. Because like what we had before, we have, in this case, we have a0 plus, then we have a1 multiplied by, and this over here, I'm going to term this s. Let me use another color just to clarify where this comes from. I'm going to go s, and we'll determine what s is shortly. But we've got s, and then we have plus, let's do our next term, which is going to be a2, and that's going to be multiplied by s, multiplied by s minus 1. S minus 1. And that is all going to be over 2 factorial. And we would continue this onwards, plus, I'm just going to do a third term just to show as well. So plus we would land up with a3 multiplied by s multiplied by s minus 1 and s minus 2. So I'm going to put the s's in to save some time. S minus 1, s minus 2, all over 3 factorial. And because we're considering for n, this will go plus dot dot dot, and we will land up with an multiplied by s multiplied by s minus 1. So s minus 1, dot dot dot, eventually multiplied by s minus n minus 1. Put the s in. And that is all going to land up being over n factorial. So this is our forward difference formula, not divided difference. And as you can see here, the pattern that you'll end up seeing is we have a0, and we have a1 times s, a2 multiplied by s times s minus 1 over 2 factorial. So each time our factorial is increasing. So this can be considered over 0 factorial, over 1 factorial, and this is going to be, we don't have an s here, we've got s, then s times s minus 1, s minus 1 minus 2, minus 1 minus 2, all the way. Notice this minus 2 is always going to be 1 less than our n. So given that, let's determine our formula. So we want to know what our first polynomial formula is of x. Oh, wait, let's first determine what our s is. So our s, this is a nice, simple and straightforward method of going about it. S, we can state is x minus x0 divided by h. Now, we need to define what these terms are. So first thing that we're going to do, let me grab this over here. Grab that. I will pull it down here, a little bit bigger. So the first thing that I'm going to look to show you is our h. So our h is going to be the difference in x. Now in this case, or in all our 4 different cases, we have to use a consistently different h. So if this was minus 1 and then minus 0.5, then minus 0.25, and then 0, we could use the minus 1, minus 0.5, and 0 because they each have an equal difference, but we wouldn't be able to use the minus 0.25. In this case, we can see each time it's separated by 0.25. So we can see that. We then land up with plus 0.25, gives you that, plus 0.25, plus 0.25. And that 0.25 is going to be our h. h is going to be equal 0.25. It is our difference. Now x and x0, well, our x0, as we have over here, in fact, I don't have a color for that yet, as we have over here, that over there is our x0, because we're considering it as our very first term. So that color is very difficult to see, so I will just write it in black. So we have x0 is going to be equal to minus 0.75. So we have determined what s is. Our x in this case, we've been told x is going to be equal to a third. So given x is equal to 1 over 3, we can then state s is going to be equal to 1 over 3 minus our x0, which is going to be minus 0.75, divided by h, which is 0.25. And if we input that, we should land up getting our term for s, and that should be approximately 5 over 3. So let's construct our P1. Now remember, our P1 is going to be a function of x, but we've defined s as a function of x. So, and we've written our P function, as you can see above. We said it was a function of x, but each of these s's, they are a function of x. So you could consider each of these as a function of x. So this is technically Pn as a function of s, but we are wanting it to eventually be a function. It is technically a function of x because s is a function of x. So just for proper full clarity, I will land up writing this as P1 as a function of s, which is a function of x. So according to our formula we have above, let me pull that up. According to our formula, we are going to have a0 plus a1 s, and that's where we stop, because we're only looking at the first terms, because n is equal to 1. We don't have any further terms. So when we land up rewriting that with our actual terms, our a0 is going to be equal to minus 0.071825 plus our a1 is going to be equal, so that is our a0, and then our a1 is going to be 0.047065 multiplied by our s. Our s is 5 over 3. So yeah, something approximately that. Now we are wanting to do our polynomial and our approximation for each of these. So when they want our polynomial, we can, in this case, indicate it in terms of s. We can indicate it in terms of s because s is a function of x. And our polynomial 2 is going to be exactly the same principle. So we're going to have our a0 plus our a1 multiplied by s plus our a2 multiplied by s minus 1 all over 2 factorial. And once again, you'll just follow the same principle. And by substituting into this, you should get your various answers. I will put down the answers at the end. I just want to make sure that everything's covered theory-wise first. So it's a very simple process, and that's how you land up getting your Newton forward difference formula. The next video I'm going to cover backwards difference, and I'll use the same data, and you'll see where I'm coming from in how to do this.